Okay, so now we finally gotten to digraphs, and digraphs are basically directed graphs. So you're going to have, let's do the definition first. D is a digraph if it has a non-empty set of vertices. Why does it have to have a non-empty set of vertices? Is because the idea behind this is it needs direction, which means you actually need, some vertices to exist for this to occur. VG, and a multiset of ordered pairs of different vertices called arcs. Now, firstly, you're like, I don't know what an arc is. So let's start off with that. So an arc is a directed edge. So the idea behind this is if you go back to your definition of a graph, we said, okay, well, you have a set of vertices and then a multiset of unordered pairs of vertices. So now you have, for the digraph, again, you have a set of vertices and you have a multiset, but now they're ordered. And because they're ordered, direction comes into play with that. So they're called arcs, they're directed edges. Okay, so for example, if we say UV is an element, well, let's do this slightly proper. UV is an element of the edge set. Okay, then we are saying that it goes from U to V. If we said VU is an element of the edge set, then we are saying it goes from V to U. So one of the very first things now to consider is like in our original graphs, particularly with our simple graphs. So let's just look at our simple graphs, and we had, the size of G was greater than equal to, well, size of G must be less than equal to n minus 1 divided by 2 greater than equal to 0. Now, because we have direction at play, the size can actually be increased, because previously we could only have UV and we didn't know which direction. So UV was equal to VU, so it only counted, for that situation. We don't have parallel edges. Now we can have a graph which has U and it goes that way and it goes that way, and they are unique edges. So they're different edges. So the one is UV, the other one is VU. They're not parallel edges because they have direction involved in them. So the size of our digraph is actually going to be the size of G less than or equal to n minus 1. So the two no longer exist because we can now break it up, and there is a possibility, of an edge going that way and an edge going that way. So that's the first thing to note. And obviously the order remains the same because the order is literally the number of vertices. Okay,